RCHUB International Foundation for Research and Education, and ISO certified.
So listen to me very carefully. The very first day, I have taught you the fundamentals of statistics, and I have explained that statistics is very simple. Statistics is done only for 5 reasons. That is, first is descriptive, which involves percentage and descriptive statistics. The second is significant association, significant difference, significant relationship, and significant influence. It is for this the entire statistics is being done. And in yesterday class, I have taught you how to feed the data into the SPSS, the questionnaire, as well as the data set. And I also have explained how to do a simple percentage analysis, the mean, median, mode analysis, and how to generate a graph, and how to perform the chi-square and correspondence analysis. So in continuation, today we are going to discuss about how to perform the significance difference test. Significance, or we will go with significant relationship test. Okay, so I told you, right? I hope you remember significant relationship test. The first and foremost thing is that the two data has to be metric in nature. The two data has to be metric in nature, and until and unless if two data are metric, we cannot find a significant relationship or not. And significant relationship can be positive or negative, right? So in order to do significant relationship test, what we will be doing? We will be doing correlation analysis. So that is what I'm going to do it right now. Actually, this is a original data set, a secondary data set that I have obtained from the MEPIDA website. MEPIDA is nothing but Marine Export Promotion Council of India, just like APIDA, Agriculture Processed Food Production and Export Promotion Council. There is Marine Product Export Promotion Council, which is known as MEPIDA. And I have downloaded the data set till 2021, I think so. Yeah, from 1996 to 2021. Okay, so this is the data set, ma. With these data set, I'm going to perform correlation analysis. So we have various marine products like shrimps, fishes, squids, dried fish, and so on. But I don't want all these things. MT represents metric ton, and crore rupees represents the rupees at which it is being exported from India. So let me check. Let me check. Yeah, let me check. Is there any relationship between the metric ton, amount of metric ton it has been exported from India, and the rupees we have got as a revenue? Is there any significant relationship? Why? Yeah, let me do that. Or else let me check with this. Is how much the total metric ton has significant relationship between the Japan, USA and European Union? I think that would do good, because the very first class someone asked me, is there any possibility to do correlation analysis with various variables? So I wanted to know how much total metric ton of marine products has been exported from India. Does the total marine products exported from India has a significant relationship with the export to Japan in metric ton, export to USA in metric ton, European Union, and does the Japan and USA has any relationship with respect to the marine product export? That also I wanted to know. So in order to do correlation analysis, what you have to do is that first you need to click the Analyze tab, go to Correlation. You see there is Correlate. And in the correlate, you will be having various options. Click on the bivariate correlations. Once you click the bivariate correlation, this following tab will be opening, and it will be asking you what all the data you wanted to compare. So here I'm going to select the data. What are the data? I wanted to know how much of export to Japan, USA, European Union, China, Southeast Asia, Middle East, and other countries have significant relationship with the total metric ton we have exported from the India. So I'm going to checkbox appears and I'm just going to click OK. You see, now we have got the output. Yeah, you see, we have got the output. So what it is saying that, yes, Japan and USA that is total export from India to Japan and metric term USA has a significant relationship. How much? It is 0.695, which means 69.5% relationship. Whenever we export marine products to USA, proportionally 69.5% proportionally we will also export to Japan. So this is what is the relationship. You see? This is what is the relationship. And Japan, whenever we export products, marine products to Japan, it has significant relationship within European Union. You may ask me, sir, how you say there is significant relationship? I told you, right? First and foremost, in the correlation analysis table, what you have to see is the significance value. If the significance value is greater than 0.05, if it is greater than 0.05, if I'm a lawyer, I'm coming with more than 5% evidence, what you will do? You have to accept me. But here it's 0.000, which is less than 0.05, which means you are going to reject me. If you are going to reject me, what it says, it means the alternative hypothesis is accepted. What is alternative hypothesis? There is significant relationship. What is null hypothesis? There is no significant relationship. Simple ma. If the value is greater than 0.05, accept the null hypothesis. What is null hypothesis? There is no significant association. There is no significant relationship. There is no significant influence or impact. But here, it's the value is less than 0.05, which means the alternative hypothesis is accepted, which means there is significant relationship between the marine product export to Japan and USA. Similarly, there is significant relationship between the marine product export from Japan and European Union, because you see it is less than 0.05. It is 0.014, less than 0.05. But if you ask, do the marine product export to China and Japan has relationship? It is no. You see, the significance value is 0.671, which is greater than 0.05, which means the null hypothesis is accepted. What is the null hypothesis? There is no significant relationship between the marine product export to Japan and China. So this is how you can easily interpret. If you have multiple data, you can compare one against one very simply using the correlation analysis. And overall also you can compare. So you see, Japan relationship with the total metric ton is 0.776. So this is how you have to interpret the correlation analysis. The very first step is that in order to perform correlation analysis, click on the Analyze tab, go to Correlate, click on bivariate correlation, select the metric data for which you need to perform correlation. Make sure the Pearson checkbox is on, and then you click OK. You will be getting the output. In the output, how to interpret the output? The very first thing what you have to see is that the significance value. If the significance value is less than 0.05, then you have to look at the Pearson correlation value. So if the significance value is less than 0.05, we can say there is significant relationship between USA and Japan. And how much there is a relationship? It has 69.5%. So how you're saying that? You're saying that by using the Pearson correlation value. The Pearson correlation value is nothing but the R value. Excuse me, ma. Okay. So now we have understood, yes, there is a significant relationship between, similarly, you can also compare against Japan. And the most important thing is that when I see many scholars, even my own scholars, what mistake they are doing is that they're putting the entire table, for for the presentation. No, it's not so. The thing is that you can either consider the upper triangle or the lower triangle, because the same thing is going to get repeated. Don't try to, as I stated before, whenever you are going to, if you have, whatever generate the SPSS output generated, put it in the Excel sheet, scrutinize it, and then you paste it in the Word document so that the viewer won't get confused. You see, the upper triangle value will be same. Say, for example, here Japan and USA is compared. Similarly, if you take a close look, USA and Japan is compared. The value will be same, 0.695000. And similarly, if you take a close look at Japan and European Union, it's 0.4777. Here also, you will be seeing the same value. Similarly, the same value in the upper triangle will be represented the down lower triangle. Any one triangle, if you consider, is more than enough. So now you have understood how to perform a correlation analysis. Now let us perform regression analysis. So I told you, right? If there is a significant relationship, then you can go for regression analysis. So in order to perform significant relationship, let me first do correlation analysis. Let me do correlation analysis for I wanted to know whether the total metric ton of marine products exported from India has a significant relationship with the total revenue we have generated in crore rupees. Obviously, it will be having, anyhow, let me check. So, total crore rupees and total metric ton. Great, super. Because we are going to perform regression analysis. For that, the basic fundamental criteria is that it should have a significant relationship. That is, here we see it's 0.964. That's really, really great. Okay, so now let us perform regression analysis. So in order to do regression analysis, so now we have understood how to do significant relationship test using correlation analysis. Now let us perform significant influence test or significant impact test using regression analysis. So in order to do regression analysis, what you have to do is that you need to first click analyze and then go to regression. And then you need to click on linear regression. I tell you what, there are different types of regressions. Yeah, there are, and using SPSS, you can perform many types of regression, but due to time constraint, we may not cover the entire thing, but I will give you the glimpse. Apart from the linear regression, we have quadratic, compound, growth, logarithmic, cubic, sine, exponential, inverse, power, and logistics, and each have its own set of criteria. For example, logistics we cannot do for metric data, and it has a set of criteria. That's the thing. Might be in near future we will be conducting a full-fledged SPSS program. At that point of time, I will be teaching you about this. Now we are going to focus on doing regression analysis using linear method. That is y equal to a plus bx. So in order to do regression, what you have to do is that you need to click analyze, go to regression, select the linear. Here it will be asking you what is the dependent data, what is the independent data. We know how much of marine products we are whatever marine products in metric ton we export, we will be getting a proportional amount of revenue. So first we export marine product, which is a independent data. And equivalently, we will be getting revenue, which is dependent data. And I tell you what, there is no significant there is no much difference in doing multiple regression, simple linear regression. Both the criteria are same. I will tell you one by one. So once you have selected the dependent and independent variable, just simply click OK. Everything is by default is correct. So don't worry. So click OK. You will be getting the following output. When it comes to regression, getting a regression fit is very difficult. But here in this case, we are getting it. That's great. Actually, when you perform a regression analysis, you should make sure that your R-square value is greater than 0.6. R square value is nothing but the forecasting accuracy. Let me repeat. R square value is a forecasting accuracy. If you take a close look, the R square value is 0.930, which means the regression equation what we are going to obtain is 93% accurate. So that is what its interpretation. So our relationship between the total marine products exported in metric ton and the revenue we have generated is 0.964, 96.4%. But the regression forecasting accuracy is 93%, which is good. After seeing this is the first fundamental criteria you have to see. If it is less than 0.6, your regression model is unfit and it cannot be considered. You have to throw away. And second, what you have to see is the ANOVA significance value. The ANOVA significance value should be less than 0.05. Here, the second criteria is also met. That is, if the ANOVA significance value is less than 0.05, we can say that our model is fit. If your ANOVA significance value is greater than 0.05, then your model is not fit and your regression, regression, what you have done is waste. You need to once again throw away. That's it. Because regression have a very strict rule. That is, your forecasting accuracy should be greater than 0.6 and your significance value, ANOVA significance value, your model fitness should be less than 0.05, and the most importantly, your coefficients. Here also it's good. Okay, your coefficients should be less than 0.05. So only then you can say that your regression model is useful, or else you cannot use your regression model. So if you take a close look, our significance value with respect to constant is also good, and this one, the coefficient, this is very important. Here, the total metric ton coefficient significance value is less than 0.05. Then we can say that, yes, the marine product we export in terms of metric ton influences the revenue. So we can forecast the revenue using the metric ton. So this is what its interpretation. You may ask, sir, how we can forecast? As the terminology indicates, the total impact this variable, which means we can forecast one variable using another variable. How? Using the formula. Let me show you. I think, let me try to be fast, but actually, the linear regression equation formula is represented by y equal to a plus b. Is it visible, ma? Y equal to a plus bx. Is it visible, ma?
Yes, sir.
Okay, so y equal to a plus bx. So this is the general formula. So you may have a question, sir, how can we forecast using this? I will show you. Okay. So this is the output we have. So generally, when you are going to copy paste, don't copy paste like this. Let me show with just one diagram how I will do the regression equation. So this is how you need to scrutinize your table and then paste it into the Word document. You see, this is a sample I just wanted to show you. Put it as font size 11. Okay, this is how you have to scrutinize the regression table. Yeah, let me come to the point. Okay, we don't have. So I told you, right? You can forecast using the that is, you can forecast the total revenue. Say, for example, the equation is y equal to a plus bx. What is y? Y is nothing but the total crore rupees, right? Total crore rupees is our revenue. Y equal to a plus bx. What is a? A is nothing but this beta coefficient. That is, I'm going to put equal to beta coefficient plus b. B is nothing but this beta coefficient into x. Say, for example, uh, let the metric ton. Let me see how much metric ton we have in last exporter. Uh, yeah, we have exported nearly 11 lakh. So let me put 12 lakh. Okay. So if you are going to export 12 lakh of marine product export. So yeah. So I think there is some mistake here. Yeah, we will be getting a revenue of 38,033 crore rupees. So this is how you have to you can predict if I'm going to export 12 lakh, then how much revenue I will be getting. If I am going to export 13 lakh, say for example, if I'm going to export 13 lakhs of marine product, I will be getting for 42,308 crore rupees of um, uh, crore rupees of revenue. So this is how we have to predict. So this is what actually regression is exclusively done to predict the future using the independent variables. So I hope you have understood how to perform significant influence test. Priorly, we have seen how to perform significant relationship test using correlation. Now you have understood how to perform significant influence test using regression analysis. So how to do significant influence test using regression analysis? Click on Analyze tab, click on the regression, click on the linear, and select the independent and the dependent variables. And once, if you wanted to perform multiple regression, that is also possible. Say, for example, let me do it for this itself. Yeah. Oh, great. Actually, we can predict. Ah, super. Actually, these should not be the output like this. So let me put it in crore rupees. Hmm, Great. Actually, here, if you take a close look, the coefficient for this, the coefficient significance for Japan is 0.684. Then we can say that no, the total revenue we have generated using marine product is not much influenced by the Japan, but it is influenced by the USA. It is influenced by the Middle East. So we can clearly say that most of the revenue we are generating is through the USA and Middle East, because it is these two things are mostly influencing our export revenue. This is how you can say. If you take a close look here, the R square value is good. ANOVA significance value is good. It is less than 0.05, but the coefficient significance value only for these two things, it is less than 0.05. For others, it's greater than 0.05. Then at that point of time, we can say that no, despite there are many independent variables, only these two variables are influencing the total revenue of the Indian marine products export. So this is how you have to say. So I hope till this everything is clear. So have you understood the concept of correlation regression and how to interpret the correlation regression. Correlation, first you have to see the significance value. Later you have to see the R value. The R value in the sense the Pearson correlation value. In the regression equation, how to interpret? First you have to look at the R square value. Then you have to look at the ANOVA significance value. Then you have to look at the coefficient significance value. Only then, if all the criteria are met, then you can consider those beta coefficient A plus B then only you can consider the beta coefficient values. So I hope you have understood how to perform the regression correlation analysis. So out of 5, we have discussed nearly 4. That is, we have understood how to do the descriptive statistics, descriptive analysis, that is percentage and descriptive statistics. We have understood how to perform significant association test using chi-square and correspondence analysis. We also have understood how to perform significant relationship test using correlation analysis. We also have performed simple linear regression and multiple linear regression, and also understood how to interpret the regression analysis, that is significant impact and influence test. And there is only one test left, that is significance difference test. So let me teach you that significant difference test. It's so are you ready, Ma? Do you have? Okay, so let me close this output, and I don't want this table also. This will complicate you further. Yeah, I think I can use this asset. Okay. Or else let me use the previous data set itself. So I told you, right, the significance difference test, what two variables has to be considered? One should be a categorical data and another should be a metric data. So, and I also have stated a criteria. I hope you remember. In the categorical data, if you have only 2 options, you can go only for independent sample T test. And if you have 2 plus options, and at that point of time, you can go for ANOVA test. Do you remember or what? So the thing is that if you are going to perform significance difference test, the first and foremost criteria is that it should, one data what you're going to consider should be a categorical in nature, and another data what you're going to consider should be metric in nature. And the most important thing is that if the categorical data has only 2 options, at that point of time, you have to opt for independent sample T test. And in case if your categorical data is having more than 2 plus options, at that point of time, you have to consider, the ANOVA test. So now let me teach you how to perform independent sample T test and how to perform ANOVA test using the same data set. The data set what we used yesterday, that is using the beverage. So we have seen in the questionnaire, right? What was, let me see the questionnaire first. So, yeah, let me consider this. You see, this is a metric data. Since it has a Likert scale based question, so I told you, right, when it is purely based on numbers, or if it is based on Likert scale based question, then at that point of time it becomes a metric data, provided the sample size should be greater than 60. We have 499 samples. So this is metric data. How you are satisfied with the product in the following aspect: product quality, product price, and product availability. Let me put all these 3 variables against 2 options. Yeah, gender, we have only 2 options. So let me do analysis with these things. So now let me perform independent sample T test. In order to perform independent sample T test, what you have to do is that you need to click the Analyze tab, go to Descriptive Statistics, click on the, go to Analyze, click on the Compare Mean, and then click on Independent Sample T test. So let me repeat once again. In order to perform the any difference test, significant difference test, first you need to click on Analyze, go to Compare Mean, click on Independent Sample T test. So it will be you will be getting the following dialog box. In the following dialog box, you have to place the categorical variable in the grouping variable. I told you, right? Categorical means groups. So you have to put that in the grouping variable. So I'm going to put gender in the grouping variable. And what is this one? The satisfaction with respect to, yeah, product, product quality, product price, and product availability. PO01. Let me put it. PO01. Yeah. PO01, 02, 03. I'm going to put these variables into test variables. I'm going to put all these three things into test variables. But if you take a close look, it will be asking, it will be having a question mark. You see? So let me define the group. If it is one, it is male. If it is two, it's female. Actually, sometimes what happens is that we have to put a variable which has more than two plus options, but we have to compare only two groups at the time. For that, this option will be helpful. Say for example, the thing is that independent sample t-test cannot be performed for more than two groups. You see, it has five options. It has five options. Yeah, D4 has five options. But if I'm going to put D4, it will accept, but it will be asking you what two groups you wanted to compare. We cannot compare all five groups. Here, what I'm doing is that I'm going to compare only the people who is going for graduates and postgraduate 3 and 4. So you can define one. I'm going to group only 3 and 4. So any two groups only you can compare at a given point of time. That is what is independent sample t-test. You cannot compare more groups, only to, categorical option with two data. So I'm going to compare gender. That's it. I'm going to click OK. So this is the most complicated part, ma. Here, many scholars get confused because you will be having three significance value. Yeah, you see, we got the output. We got the output. Please consider both the tables. Don't delete any tables. And apart from this mean difference, standard error is not much required. You can delete all these values. Put the group statistics as well as the significance. And here where the many scholars get confused, please pay attention. Pay significant amount of attention, because the thing is that you see here is one significance value. And here, if you take a close look, there is two significance value. Now you may have a question. Previously, we have seen only one significance value, but here there are three significance value. What significance value do we need to consider? The first and foremost, I told you, right? If the significance value is less than 0.05, if it's less than 0.05, you need to you need to reject. You need to reject. If it is greater than 0.05, you need to accept. If you take a close look here, here is less than 0.05. So you have to reject this significance value, that is 0.041. You need to accept this significance value, that is 0.064. In case if this significance value instead of 0.01, it is 0.06, it is greater than 0.05. At that point of time, you need to accept this significance value straight to it, 0.182. So end of the day, you should consider the significance, two-tailed significance value, and how to select one among these two is that it is based on this particular significance value. So if it is greater than 0.05, accepts the thing that is straight to it. If it is less than 0.05, reject this and go for the down one. Okay. So this is how you have to, now let me first stop this interpretation. So we have compared gender against the satisfaction. So this is what is our aim, right? So what is our hypothesis? There is significant difference in the level of satisfaction with respect to male and female in terms of product quality, product price, and product availability. So this is what is our hypothesis. So we can consider only one variable because in most of the cases in the management studies, we will be under one factor, we will be using many questions. For that sake, I have put all these three things as an example. So we can say there is significant the null hypothesis is there is no significant difference in the satisfaction level of the male and female respondents with respect to product quality, product price, and product availability. So now let's check. You see the significance value, it's less than 0.05 for all the cases, which means we need to reject this, the upper significance value, and consider only the significance value down to it. If you take a close look, it's greater than 0.05, uh, which means we need to accept it. Accept the null hypothesis. What is null hypothesis? There is no significant difference in the satisfaction level of the customer being male or female respondents with respect to product quality. But with respect to product price, we see it's less than 0.05, which means they have significant difference in satisfaction level for the male and female respondents. And for even for the product availability, their opinion on satisfaction level is same. Let us take a close look at the mean score value also. If you take a mean score value, the product quality, it's 3.7 and it's 3.5, almost 3.55. It's almost close. And product availability, it's 3.8 and 3.67, which is also 3.7, which is also so close. But if you take a close look at product price, it's 3.8 and 3.2, which means female says that the product price, they are actually close to neither agree or nor disagree about the product price. Whereas male candidates 3.8, which is close to 4, they say, okay, this product price is agreeable. Whereas the female says the product price is not agreeable. So this is what is the interpretation. So you need to put all these two tables, but no need to consider this mean difference and these other things and all. But you need to highlight a proper significance value. So this is the most toughest interpretation, ma'am. Many scholars make so many mistakes while writing interpretation because of these three significance value. I hope you have understood this clearly. So now let us perform the ANOVA analysis. Now let me explain you how to perform an ANOVA analysis. In order to perform ANOVA analysis, what you need to have, you need to have a categorical data and a metric data, and you need to make sure that the categorical data has 2+ options. So let us consider the very same question itself, that is about the education. So in order to do ANOVA analysis, go to compare me, click on one-way ANOVA. So in one-way ANOVA, where is that thing? Highest level of education, and I'm going to consider the same variables. Yeah. And I want the descriptive statistics also. Yeah. Now I got the descriptive statistics and the output. And if I take a close look, oh my God, all the significance value is less than 0.05, which means there is significant difference in opinion among the respondents who have completed only schooling, who have completed diploma, graduate, postgraduate, other professional degrees. There is significant difference in the satisfaction level of the respondents belonging to different educational level for the product quality, product price, and product availability. Let us look at the mean score. Yes, there is some mean score difference. Sometimes it is with 2.8, it is 4. There is a significant mean score difference. Yeah, this is how you have to interpret. So end of the day, you need to look at the here you will be having only one significance value. So if the significance value is greater than 0.05, we can say that there is no significant difference in the satisfaction level of the customer belonging to different educational level. But here it is less than 0.05, which means there is significant difference in the satisfaction level of the respondents belonging to different educational level. So this is what is our interpretation, and not just with the product quality, product price, and product availability, for everything. Okay, so this is how you have to interpret the ANOVA. So now let me clarify the one sample t-test and paired sample t-test. I told you, right, many people will be performing one sample t-test with the categorical data. It is completely illogical, as I stated before. And I told you, right, when it comes to one sample t-test, you need to have a standard value. Say, for example, actually, this is a real data set. Actually, this is a real data set of actually data collected from a service center, Royal Enfield Service Center. You see, we have collected what is a bike mileage at the time of purchase, what is a mileage before the first service, what is a mileage after the first service. I don't want to put, yeah, I don't want to use these things. Okay, so first, actually, the company have claimed that this Royal Enfield Meteor 350 have claimed that in the highway, generally the Meteor 350 will be giving the mileage of 35. So, in order to perform one sample t-test, you need to click on Analyze, go to Compare Mean, and click on One Sample t-test. If you click One Sample t-test, you will be seeing the following dialog box where the variables and the test value. The test value is nothing but the standard value. You see the bike mileage at the time of the Meteor 350 bike will be giving a mileage of 35. That is what the company have claimed. So 35 is the test value. You see, don't put any value. Sometimes people will put zero here as it is. They will leave the value zero here, and which means it is completely wrong. It will be comparing the mean score against zero, which will be always different. Please don't make this test. If you encounter a situation like this, if you have a test value, if you have a standard value, put that in the test value. And if it's a metric data, put it in the test variable and then click OK. You will be getting the output. Now, where is output? Yeah, yeah, great. We got the output. You see the mean, the mileage in the, oh my God. Okay, actually, bike, the Meteor 350, the company have claimed it will be giving only 35 kilometer per liter. 35 kilometer per liter. But the test value is 35. The test value, you see, test value is 35. But the on an average, nearly 15 bike which is been tested is giving a mileage of nearly 38.6. Not much difference, but still it's 3 kilometer. Okay, right. So, but under 5% confidence interval, there is no much difference. Let us see. Yeah, uh, you see nearly 20 bikes is been tested. So the significance value is 0.000, which means there is no significant difference. There is no much significant difference in the mileage ensured by the company and the mileage given by the given by the bike in reality. So we can say yes, what we have stated, the bike is performing. So this is how it is. Only under this criteria you can perform one sample t-test. In order to perform one sample t-test is that first and foremost is that you need to have a standard value, and the standard value is measured against the mean value. If there is no much significant difference, you can say that there is no significant difference in the company claimed mileage and the actual mileage. So here it is the result. You see, uh, so now let us perform the paired sample t-test. So paired sample t-test, I hope you remember. So when it comes to paired sample t-test, you should be using the same set of sample before and after time interval. Say, for example, what was your knowledge on statistics and SPSS before this before 3 days, and what is your knowledge on statistics and SPSS after this program get over? So is there any significant difference in the knowledge level of my students who are pursuing under me? So it is what this paired sample t-test. So under paired sample t-test, I told you, right, here the categorical data is nothing but the sample itself. So there is no categorical data to be mentioned here. Only the metric value will be compared. So in order to perform paired sample t-test, what you have to do is that you need to once again go to compare mean, click on the click on the paired sample t-test. And it will be asking you what are the variables 1 and variable 2. So you see the mileage before the first service, mileage after the first service, mileage after the first service. I wanted to know after nearly for 2,500 kilometers, we need to do the first service for the vehicle. So during my first service, what was the mileage? And after me giving the service, is the mileage have improved or it is remaining the same? Because after the first service, the mileage has to improve. So let me check it out, check this out. You see, there is no difference in the mileage itself. Yeah, there is difference actually. Okay. So if you take a close look here, here the mileage before the first service was 40. And mileage after the first service was, it was 41.6, actually nearly 1.3 kilometer per liter. The mileage have been increased. There is, but this is under 5% confidence interval is not a big difference. Actually, we need to have more than 5 as a difference. So let us take a close look at the output. So as I stated before, in paired sample t-test, you need to look at the significance value. Yeah, you see the significance value. Oh, sorry. In previous case, I have taught you wrongly. You see, the significance value is less than 0.000, which means there is significant difference in the company claimed mileage and the actual mileage. The company claimed mileage is 35, but the bike in actual it is giving 38.6, which is 3.6 kilometer per liter higher. So this is the interpretation. So sometimes I used to get, please don't mistake me, ma. The thing is that this is the interpretation. You see, the significance value is less than 0.05, which means the null hypothesis is rejected. If the null hypothesis is rejected, means alternate hypothesis is accepted. What is alternate hypothesis? There is significant difference in the company claimed mileage and the actual mileage. The actual mileage is 3.6 kilometer per liter higher actually, which is a good sign, really good sign. And if you take a close look at this service center, it's not performing good because we see during before the first service was 40 and mileage after the first service was 41.6, which is just 1.3. You see, the significance value is 0.148, which is greater than 0.05. Then we can say that there is, since it is greater than 0.05, greater than 5%, we can say that the null hypothesis accepted. What is null hypothesis? There is no significant difference in the mileage before the first service and after the first service, which means they need to improvise their service in order to get better reputation and brand name, because the mileage before the first service and after the first service is not significantly different. They are almost the same, which is not acceptable. If you're doing service, the bike mileage has to increase, the bike performance has to increase, the bike power and other things has to increase, but it is not happening. So they need to employ a different strategy, for which also there actually we have collected the data that I cannot illustrate right now. So I hope you have understood. The thing is that the same set of sample, but two different time intervals. Only in that case, you need to perform the paired sample t-test. And the one sample t-test is like you have a standard value and you're going to compare against the other, your test subjects, all the test subjects, what you're going to consider. At that point of time, you can use one sample t-test. If you have categorical data with more than 2+ options, you can go for one way ANOVA. You have only 2 options, you can stop with independent sample t-test. So we have discussed all 5 different all the 5 different reasons for which the entire statistics is performed. So apart from that, there are some other things what you can do using the SPSS, like exploratory factor analysis, cluster analysis, Non-parametric test is similar to this called as Wilson test. We have Man-Whitney U test and other such tests. And you can also perform some other optimal scaling test, and you can generate some different forms of graphs. But the thing is that the time is very much constrained, ma. Might be in near future, we will be conducting a elongated section of this SPSS. At that point of time, if time permits, I will surely teach you. Okay. So this is actually the foundation. And if you understand this clearly, obviously you may end up learning everything in the SPSS, because this being the foundation, if you understood clearly, everything is easy for you to understand. So with this, the entire statistics is over. That is the fundamentals of entire statistics is over. So we have understood how to perform descriptive analysis, the percentage and mean, median, mode, skewness, and kurtosis analysis. We have discussed how to perform significant association test using chi-square and the correspondence analysis. We have discussed how to perform significant relationship test using correlation analysis. We have understood how to perform significant impact or influence test using regression analysis. And we have also understood how to perform various types of significance difference tests using one sample t-test, one-way ANOVA, independent sample t-test, and paired sample t-test. So with this, the foundational SPSS course is over, ma. Do you have any other doubts in today's session or with respect to your research? You feel free to ask me right now, ma. So anyone, any doubts? So is everything clear in today's session? And if you have any doubts, even with respect to your own research, you may feel free to ask me, ma. So everything is clear. Um, Host, do they have chat? Yeah, I got the chat. Okay, sir. Okay. Okay, what is the difference between one-way ANOVA and two-way ANOVA? Why this ANOVA test is done? See, one-way ANOVA, just the formula is different, ma, and the accuracy is more with respect to two-way ANOVA. But with a 95% confidence interval, one-way ANOVA holds a ghost. Actually, these are, simply speaking, these are two different techniques, but yielding only the same result. That's it. So don't get confused. There's the protocol of obtaining the answer is different, but the result will be same. Why ANOVA test? Why ANOVA test? In the sense I told you, right? It's when you wanted to measure the significant difference. Say, for example, one is a scooter. Instead of scooter, it's a Honda Activa and Jupiter. And you wanted to, what are the two groups here? Honda Activa and Jupiter. And you wanted to know whether there is significant difference in the mileage between the Honda Activa and Jupiter. So you are measuring it. The Honda Activa is giving a mileage of 32 and Honda Jupiter is giving a mileage of 36. So there is a significant difference, right? So if one data is categorical in nature, another data is metric in nature, at that point of time, you will be measuring the significant difference or not. It is for that these ANOVA tests are done. Generally, one-way ANOVA, the protocol is simple and the result result will be, you will be getting the result within a simple time frame. Whereas the two-way ANOVA, sometimes mostly in experimental research, you will be using two-way ANOVA, where you will be using the 99% confidence interval. If you put 99% confidence interval in the SPSS itself, we will go for automatically two-way ANOVA analysis. That is, it will in the normality distribution curve, it will neglect the here 2.5 and that 2.5 for 95% confidence interval. Here it will be rejecting only 0.05 and 0.05 here. So the protocol will be just the formulas and the protocol for deriving the result is different, but you will be yielding the same result only. So anyone, any other questions, ma? Or non-significant. Actually, it's a statistical terminology. Generally, we will say there is significant difference or a significant association. Significant in the sense, it say for example, in social science studies, we will be telling 5% error is acceptable. Sometimes in analysis, the experiments, we will be telling only 1% error is acceptable. That 1% error, that 5% error is the significance level. So significance or confidence interval. So if the significance what when we tell, it illustrates the confidence interval. Say we can say confidently that whenever when I say there is significant association, it is 95% accurate. Similarly, if a person who is belonging to a science study, when he says, yes, there is significant association, he is saying with 99% confidently, because there is only one chance of error. So that is what statistically significance is all it means. Many statisticians, when they say significant, it means it's a confidence interval, ma. Sir, can we apply t-test for two or more variables or Pearson correlation? T-test for two or more, I told you, right? Here it's different, mind. Pearson correlation, all your variables should be metric in nature. And in case if one of your variable is categorical in data and another variable is metric data, at that point of time only you can opt for t-test. So you need to decide by yourself if what your two variable is all about. If to and in case if and the thing is that you are having two or three variables which are categorical in data and two or three variables metric in data, you have no other option. You have to go one by one. Then you have to perform t-test one by one. There is something called as multivariate test, that is multiple ANOVA, that is MANOVA. That I have not taught you as of now because due to limited that is not in our scope. You can also do that also. Okay, just remember what I've said. There is something called as MANOVA, multivariate test. You can do that. That is one shot at with all category data, making all metric variables analysis. But based on the variables only, you have to decide. If it's categorical data and metric data, you have to opt only for t-test. If all things are metric data, you have to opt only for correlation analysis. So both are different criteria, ma. Okay. So one should be metric data and one should be categorical data. And that categorical data should have more than 2+ options. Only then ANOVA. Say for example, what is your gender? Male, female. It has 2 options. You have to go for independent sample t-test. And if it is having male, female and transgender, the third option, and this customer satisfaction level, strongly, highly satisfied with the 5-point Likert scale. At that point of time, you have to go for ANOVA analysis. If both the data, that is satisfaction and the sales, if both are metric data, right? At that point of time, you need to go for correlation analysis. Okay, Mas. So is everything clear in today's session? Okay, thank you all. Thank you, God. We see. Take care. Bye.
Contact RCHUB International Foundation for Research and Education. WhatsApp 9888 231 231.